To find the equation of the diagonal BD, we first need to find the midpoint of diagonal AC, which we use this formula to find it. Negative 2 plus 4 divided by 2, negative 5 plus 7 divided by 2. We should then find the midpoint of AC, which should then become negative 2, become 1 and 1. Next, we need to find the line equation of AC first before we can find the line equation of BD, which we use the formula of y equals mx plus c. Now to find the values of this gradient, which is m and also c, we can use the implement the coordinates of the midpoint 1 and 1 also, when one of the two is a and c, which then become y equals to 7 equals to 4m plus c. So 1 equals to m plus c. We find the value of m by using this formula, which can become 1 minus c equals m. Now, since we know the value of m, we can implement this thing here. It will then become 7 equals 4, 1 minus c plus c. So it then become 4 minus 4c plus c. Then it become 4 minus 3c equals 7. Now that we have this equation, we can now also find c, which then becomes 7 equals 7 minus 4 equals negative 3c. Become 3 equals negative 3c. Then these two 3 divided by negative 3 equals to negative 1 equals to the intercept of the line equation AC. Now to find the gradient, we just need to implement negative 1 into the y equal mx plus c formula earlier. So it become 11 equals 4m minus 1. Which we can now find m by using this formula. 7 minus 1 plus 1 equals 4m. Which then become 8 equals 4m. So we can make this become 8 divided by 4 equals m. It becomes 2 equals m. Now we have the gradient for the line equation AC, which is 2. So now the line equation of AC is y equals 2x minus 1. Now set in a rhombus, the two diagonals is shown here. Actually bisecting each other at 90 degrees, which means since the bisecting each other at 90 degrees, there's actually a formula saying that the two gradients of these two line equations, which the first one is this one, another one is the unknown. We don't know that, which is basically the line equation of diagonal BD multiplied by each other will actually equals to negative 1. Now knowing this, we can actually now find the gradient of diagonal BD by saying this, which means 2 multiplied by g, which let's say g is the gradient of diagonal BD, will equal to negative 1, which then can turn to 2g equals to negative 1. Now we can find g easily by letting g equals to negative 1 divided by 2. So now we have the gradient for the line diagonal BD. Now since we know the gradient of the line equation of diagonal BD, we can find the point intercept of the line equation of diagonal BD by using the coordinates of 1 and 1. Since 1 and 1, the coordinates of these coordinates is the midpoint, is also the midpoint of diagonal BD, since the rhombus, the two diagonals have the same exact midpoint. So it become 1 equals to 1 over 2 x plus c, which now we can now easily find what intercept as 1 equals to negative 1 over 2 plus c, since the x is actually equal to 1. So now using this, we now find 1 plus 1 over 2 equals to the 1 intercept. This means that 1 with 1 over 2 is the 1 intercept. Now, since we now have the 1 intercept of the line equation of the angular BD, we now successfully found the answer in the question A, which is y equals to negative 1 over 2 into the gradient of the line equation x plus 1 with 1 over 2. Moving on to question B, it says us to find the coordinates of B and D. Firstly, we must find the line equation of the line BC, side BC. Since we already have given that the gradient of the line BC is 3, we can use this y equals to 3x plus c. We know the y and we can use example of c, the coordinates of c is 4 and 7, since the line BC is the coordinates of c 4 and 7 is a part of line side BC, so we become 7 equals to 3 times 4 plus c. We become 7 equals to 12 plus c. So in this we now become 7 minus 12 equals to c, which is basically negative 5 equals to 1, the 1 intercept of the line equation of BC. Now we know the line equation of BC, which is y equals to 3x plus minus 5. Now since we have the line equation of the two lines here, which these two lines, this one is this one and this one and this one, they both intersect at the coordinates of B. And now since we know that these two lines intersect, we actually find the coordinates of B, the point of the intersection of the two lines, by implementing, for example, 3x minus 5 into this formula here, which means since these two equals to y, divided at this as like this, 3x minus 5 equals to negative 1 over 2x plus 1 with 1 over 2. So now we can find x by finding 3x plus 1 over 2x equals to 1 with 1 over 2 plus 5. So become 3 with 1 over 2x equals to 6 with 1 over 2. You can now find x by using this 3x equals to 6, divide it as 6.5 divided by 3.5. So basically these numbers are here. So now we have found the x coordinate with the coordinates of B. And now to find y is using the same method. So it become y equals to 3 times 6.5 divided by 3.5 minus 5. So it then become 19.5 divided by 3.5 minus 5. This will then finally become 4 over 7. So we have found the coordinates for the point B, which is 6.5 over 3.5 into y coordinates being 4 over 7. Now to find the coordinates of D, is to note that we can use the same method as finding the midpoint. Since B and D are on the same line and they have the midpoint, since we know the coordinates of B and D, B and the midpoint of BD, we can now find D by using this formula, which is the same formula as we found the midpoint of AC. 6.5 over 3.5 plus x, which is we can use x as saying the x coordinates of D divided by 2, 4 over 7 plus y is y being the y coordinates of the coordinates of D divided by 2 equal to 1 and 1. Now doing this, we can find the value of x and y with 6.5 divided by 3.5 plus x equals to 2. Since 1 times 2 here, which will then become x equals to 2 minus 6.5 divided by 3.5. So then becomes 1 over 7. And the same goes for y, which is 4 over 7 plus y equals to 2. Y equals to 2 minus 4 over 7. So then becomes 10 over 7. So now we have now also found the coordinates for D, which is 1 over 7 and 10 over 7. This we have found that